Hello students, we previously saw what are soaps and detergents. They are chemically sodium or potassium salts of long chain of fatty acids. We saw that they are represented like this. If you observe this one molecule of soap or detergent, it contains two chemically distinct parts. First is this ball-like head which has the functional group and metal ion attached to it. This is the hydrophilic end. But why this name? Hydra is water, as we know, and philic is derived from philus, meaning loving. This means that this end loves being with or around water. This hydrophilic part is itself polar, so it gets attracted to polar molecules like water and thus also referred to as polar end. In contrast, this second wavy part, the tail, is called the hydrophobic end. Phobia, as we know, means fear. That is, end which fears or hates being around water. This means that this end keeps itself away from water. And this hydrophobic part is itself nonpolar and gets attracted towards nonpolar molecules like dirt and oil and is thus referred to as nonpolar end. Now that we know the typical structure of soap or detergent molecule, let's understand how it helps in cleaning our clothes or utensils or our bodies. Could we use only water for cleaning instead? Not really. Using only water might not be enough sometimes, as some kinds of dirts, especially oils and grease, are really stubborn and cannot dissolve in water. That is the reason why oily stains on clothes or oily particles on utensils cannot be removed from them by using only water. Thus, soaps and detergents are chemicals that are used for cleaning purposes that help us to remove all types of stubborn dirt or any oily substance. But how is this cleansing action carried out? Let's understand it. As we know, soap or detergent molecules have a head which is hydrophilic or polar and a tail which is hydrophobic or non-polar. When a soap or detergent made up of many such molecules is dissolved in water, these molecules align themselves in a particular manner. And why is this so? Correct. As tails being hydrophilic, they tend to move away from water and they come near to each other to form the core, which keeps them away from water. In contrast, as the heads are hydrophilic, they tend to stay near the water molecules facing outwards. They form a ring-like structure, as you can see here. This type of clusters have specific name. Yes, micelles. Now technically this micelle is not soluble in water and remains suspended as colloids in the solution. And how does this work? Let's assume this is a stain or dirt molecule on cloth. Next, as we know, the non-polar hydrophobic tail gets attracted strongly towards the dirt or oil, so it sticks to the oil and covers all around it. The soap molecules arrange themselves, trapping the oil in the center. As you can see, the polar hydrophilic heads point outwards near the water, and the tails point towards the dirt or oil. The agitation activity of washing facilitates these micelles to leave the surface of cloth and they get washed away along with the water, carrying the dirt molecule or oil stain along with them. And all along with the micelles, dirt or oil also gets washed as they are trapped inside it. This is because the charged polar end of soap molecules makes the micelles along with the dirt soluble in water. Thus, the dirt or stain is washed away with the soap or detergent. This is how soap or detergent works. But students, have you ever observed that while washing, sometimes an insoluble substance that is grayish and sticky remains on the cloth? This happens in conditions when we use hard water for washing. And this insoluble material is called scum. As I told you in our previous video, that scum is formed due to salts present in hard water. Actually, these salts react with soap molecules to form insoluble products which are grayish and sticky. So they leave a deposit on clothes or skin and does not easily rinse away. Over the time, this can lead to deterioration of fabric and eventually ruin the clothes. Thus, these soaps cannot be used conveniently in hard water. Now, this problem is overcome by using another class of surfactants or cleaning agents called detergents. The development of synthetic detergents was a major achievement in field of cleansing. These detergents possess the desirable properties of ordinary soaps and can be used with hard water. They also have great cleansing ability. So we can conclude that cleansing action of detergents is better than soaps. So now students, what we have seen is how detergents or soap can clean dirt or stains by forming micelle-like structures.